Now let's put all this to practice and try to recreate something more specific. We're going to be trying to make something like a smoke portal. It's going to be kind of a smoke vortex. We'll start the same way, so we'll create a geometry container. I'm going to call this smoke vortex. We're going to have a slightly different approach in terms of how we're going to be structuring our file. But just so you know that you can do things in different ways. So for the smoke vortex, we're going to start by creating our source. And our source is also going to be a torus. We're going to orient the torus along the z-axis. Okay, something like this. Let's keep the radius at 1, but make it much thinner, 0.1. I'm also going to need a lot more subdivisions because I want to deform this. So let's say we have, if we have 16 rows, we should have around 64 columns. So times 4. Let's copy this parameter, base relative reference, and just multiply it by 4. And that way we just need to adjust this one. I think 32 is going to be okay. Yeah. Next, I want to have this rotate. Let's create a transform. And let's animate the rotation. Let's say on the z-axis, we're going to use time times 200. Let's make sure to turn on the real time. So it is spinning quite fast, but if you have a lot of subdivisions, you might get the optical illusion that it's not moving that fast. But this way we can see that the velocity at which it's spinning is actually pretty good. Let's put this back to 32. But yeah, it was giving us the sensation that it was actually not spinning all that much and on the opposite direction. Now, it would also be nice for us to have some kind of deformation to this, the overall shape, just so it's not as perfect. So let's create a point warp. Pretty standard procedure here, so we're going to use a turbulent noise. It's going to be sampling the position. It's going to be a 3D noise. And we're going to add this value to the current position. And output a new position. Now here the turbulent noise, let's right click, and here on the vex create input parameter, so it automatically creates all the inputs. And now we can just, I'm going to call this deform shape. Okay, so I'm not going to use alligator noise, I'm going to use original Perlin noise. I'm going to keep the frequency the same for all the dimensions. Copy parameter, base relative reference, base relative reference. So all axes have the same frequency. Start with something fairly small. And this way we have that deformation. Let's animate this as well on the z-axis. I'm going to say that the offset is going to be equal to time times 2. Probably still a bit too much. Let's put the roughness down and maybe just skip time. Okay, we can also try apply the rotation after. Rotate. Let's try and change the order of things here. Of course, for this rotate, we should use the centroid. Okay, so here on the pivot transform, let's make sure we're grabbing the center. Okay, so we're grabbing the 3 coordinates for the centroid, and that's going to make sure that even though the shape is changing, the rotation is going to happen based on the pivot point, the centroid of that shape. So it should give us something more unstable, but also more interesting. Cool. So one thing we can do, and that's probably a good idea, is to push this up so we have a bit of room so it's not intersecting the ground. So we can do that right away. Apply transform. Let's grab the radius here, copy parameter, paste relative references, and let's just multiply this by 1.5. In that case, if we decide we want to bring this down, it's always going to keep a good distance between the ground. Let's keep this at 1. See how this is working. So as you can see, the rotation still works because it's centroid, because it's based on the centroid of the object. Still a bit too wobbly here. Maybe the frequency or the time a bit slower, 0.8, and here the frequency maybe 0.08. Okay, let's try a bit higher. Yep, I think this is more interesting. It's probably too wobbly, but I think it's good. We can also control the amplitude here. Maybe 0.6 is enough. Yep, we got a nice wobbly portal. Now, if we want to have, remember when I told you before that we really need to have a good source in order to be able to have a good and an interesting smoke simulation. So with that in mind, let's add a mountain to this. And the mountain is going to be used for us to have smaller detail, smaller changes happening on the surface. So again, the height is too strong, maybe 0.4. The element size 0.5. The element size, I don't know, maybe 0.5. Okay. Even though this is rotating, the rotation is happening before the mountain, so it might be a good idea to try it the other way around. Yep. Now we do need the mountain to change as well, so I'm going to use an offset 500 randomness, and then we'll use time again. So that way it's changing and rotating, so we have a lot of variation happening. We should keep a minimum amount of thickness, so maybe 0.4, and here maybe times 2, so it changes faster. Okay, a lot of irregularity. I'm going to change the length of our timeline to 96. It's enough. Yep. Now we'll also use let's calculate the normals. Let's put a normal here. We can use the normals later to convert the normals into velocity as well. So if we have a look at the normals, let's put these 2 points. They're always going to be changing as well because of the mountain. So that's going to give us some interesting variation as well. Now the workflow, as we saw before, it's going to be start by creating a pyrosource. We'll have this as a pyrosource. We'll initialize smoke. That's what we want to source. And here on the mode, let's use the volume scatter. I'm going to reduce the particle separation 0.05. Let's change the background as well, so we have a better idea of what's happening. Put this to dark. And I might create the camera right now. Let's put something like this. Yeah, I'm going to create a camera here. Control, click on the camera.